Examsnet. Welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. Let's start this session. Here is a question. The range of the real valued function f of x is equals to x square plus x plus 1 divided by x is. We have to find the range of this function. Let y is equal to x square plus x plus 1 divided by x. Therefore, on cross multiplying, it will be xy is equal to x square plus x plus 1. Or we can write it as x square plus x plus 1 minus xy is equal to 0. So here a will be equals to 1, b will be equals to 1 and c will be equals to 1 minus xy. Now we have to calculate the value for discriminant. So it will be x is equal to minus b plus minus under root of b square minus 4ac divided by 2a. On putting the values, this will be equals to minus 1 plus minus under root of 1 square minus 4 into 1 into 1 minus xy divided by 2 into a, which is 2 into 1. So it is 2. On further solving, x will be equals to minus 1 by 2 plus under root of 1 minus 4 into 1 minus xy, which will be equals to minus 1 by 2 plus under root of minus 3 plus 3xy. On further simplification, x will be equals to minus 1 by 2 plus under root 3 minus 1 plus xy. We can also write it as minus 1 by 2 plus under root of 3 xy minus 1, which is equal to minus of infinity. Now let x is equal to x square plus x plus 1 divided by x. So on cross multiplying, it will be x square is equal to x square plus x plus 1. Therefore, x square and x square will be cancelled. So x plus 1 will be equals to 0. X will be equals to minus 1. So the range will be minus infinity to minus 1. Also, 3 and infinity. Therefore, we can say that this is the range of the given function. So the correct option for this question is minus infinity minus 1 union 3 and infinity, which is option number D here. Next question is also relation and function. If a function f is to r such that r is defined by L and such that r is defined by M, and they are defined by a function f of x is equals to x plus 3 divided by x minus 2 is a bijection, then 3L plus 2M is equal to. We have to find the value for 3L plus 2M. Let y is equal to x plus 3 upon x minus 2. On interchanging the variables, this equation becomes x is equal to y plus 3 divided by y minus 2. We have interchanged the variables here. Now, on further cross multiplying, y plus 3 will be equals to x into y minus 2. Therefore, y plus 3 will be equals to xy minus 2x. So, y minus xy will be equals to minus 2x minus 3. Taking y common here, it will be 1 minus x is equal to minus 2x minus 3. So, y will be equals to minus 2x minus 3 divided by 1 minus x. Or we can write it as y is equal to minus of 2x plus 3 divided by 1 minus x. Now we have to calculate the f inverse x. So f inverse x will be equals to minus 2x plus 3 divided by 1 minus x. Here you can see that L is equal to 2 and M is equal to 1. We have to calculate the value for 3L plus 2M. So substituting the values here, it will be 3 into 2 plus 2 into 1, which is equal to 6 plus 2, which is equal to 8. Therefore, we can say that the required value is 8. So the correct option here is option number C, which is 8. Next question is a question that comes from matrix. And the question is, if matrix A is equal to x, 0, 1, 1 and matrix B is equal to 8, 0, 7 and 1, and it is given that A cube is equal to B, then x is equal to. So first let us calculate A cube. We know that A square is equal to A into A. So A into A will be x, 0, 1, 1 into x, 0, 1, 1, which will be equals to x square, 0, x plus 1 and 1. Therefore, A cube will be equal to A square into A, which will be equals to x square, 0, x plus 1, 1 into A. A is x, 0, 1, 1. On multiplying both this matrix, we will get x cube, 0, x cube plus x square plus x plus 1, and here we will get x plus 1. We have found the value for A cube. It is given that A cube is equals to B, means the value which is x cube, 0, x square plus x plus 1 and x plus 1, it is equal to B. Matrix B is 8, 0, 7 and 1. Now comparing the first term, which is x cube here and 8 here, we can say that x cube is equal to 8. So from here we can easily calculate the value for x. X cube will be 2 cube, so x will be equals to 2. Therefore we can say that the value of x here is 2. So option number D is the correct option for this question. Next question is, if B and C are non-zero real numbers and matrix A is 1, B, C, B, 2, 3, C, 3, 4 and matrix B is 0, B, C, minus B, 0, 2 and minus C, minus 2, 0, then determinant of A plus B is. We have to calculate the determinant of A plus B. So first let us calculate A plus B. This is matrix A and this is matrix B. So A plus B will be equals to 1, 2B, 2C, 0, 2, 5 and 0, 1, 4. This is the value of A plus B. Now determinant of A plus B will be written as 1, 2B, 2C, 0, 2, 5 and 0, 1, 4. We have to calculate the determinant. So further expanding this term, it will be equals to 1 into 2, 5, 1, 4 minus of 2B into 0, 5, 0, 4 plus 2C into 0, 0, 2, 1, which will be equals to 1 into 8 minus 5 minus 2B into 0 plus 2C into 0, which is equals to 3 minus 0 minus 0, which is equal to 3. Therefore, we can say that the value for determinant of A plus B is 3. So option number A is the correct option for this question. Next question is also from the matrix. If the rank of the matrix A is 2 and K is a real number, then K is the root of the following quadratic equation. See, if K is the root of the quadratic equation, it means that it should satisfy the equation. So let us look at the first option. The first option is x square plus 3x plus 2 is equal to 0. Now finding the roots of this equation by splitting the middle term, this will be x square plus 2x plus x plus 2 is equal to 0. Taking x common, this will be x plus 2. Taking 1 common, this will be x plus 2 is equal to 0. So x plus 2 and x plus 1 is equal to 0. Therefore, x will be equals to minus 2 and x will be equals to minus 1. But you can see that both these values are negative and both values cannot be negative. So we can say that this option is not correct. Now let us look at the second option. Second option is x square plus x minus 2 is equal to 0. On factorizing it, it will be x square plus 2x minus x minus 2 by splitting the middle term. Taking x common here, it will be x plus 2. Taking minus 1 common here, it will be x plus 2 is equal to 0. So the factors will be x plus 2 and x minus 1 is equal to 0. Therefore, x is equals to minus 2 and x is equal to plus 1. You can see that here in this equation, one value is negative and one value is positive. So this is the correct equation which have k as a root. Therefore, we can say that k is the root of the equation x square plus x minus 2 is equal to 0. So option number B is the correct option for this question. Next question is, if the solution of the system of simultaneous equations 1 by x plus 2 by y minus 3 by z minus 1 is equal to 0, 2 by x minus 4 by y plus 3 by z minus 1 is equal to 0, and 3 by x plus 6 by y minus 6 by z minus 4 is equal to 0, then x is equal to alpha, y is equal to beta, and z is equals to gamma, then alpha square plus gamma square is equal to. Here, let 1 by x is equal to u, 1 by y is equal to v, and 1 by z is equal to w. So the equation becomes u plus 2v minus 3w is equal to 1. Let this be equation number 1. Similarly, 2u minus 4v plus 3w is equal to 1. Let this be equation number 2. And 3u plus 6v minus 6w is equal to 4. Let this be equation number 3. We know that there is an expression which is a into x is equal to b. So x will be equals to a inverse b. So we have to calculate a inverse here. So by this given equations, a is equal to 1, 2, minus 3, 2, minus 4, 3, and 3, 6, and minus 6. X will be equals to u, v, and w, and b will be equals to 1, 1, and 4. I hope that it is clear to you how we have formed the matrix. The equations are given. We just have to put the values here. So matrix A is 1, 2, minus 3, 2, minus 4, 3, 3, 6, and minus 6. So let us calculate the modulus of A. It will be 1 into 24 minus 18 minus 2 into minus 12 minus 9 plus minus 3 into minus 12 plus 12, which will be equal to 6 plus 42 minus 72, which is equals to minus of 24. We have to calculate A inverse, and we know that A inverse is equals to adjoint of A divided by modulus of A. So let us calculate the adjoint of A. Adjoint of A will be equals to 6 minus 21, 24, 6, 6, here there is minus 3, minus 9, and 0 and 8. Transpose, its transpose will be the adjoint. So we can say that adjoint of A is equals to 6 minus 6, 6, minus 21, 3, and minus 9, 24, 0, and 8. This is the adjoint of A. We have to calculate A inverse. So A inverse will be adjoint of A divided by modulus of A. Modulus of A is 24 of minus, so it will be minus 1 upon 24 into the matrix 6 minus 6, 6, minus 21, 3 and minus 9, and 24, 0 and 8. Now we know that x is equals to A inverse B. So x will be equals to minus 1 by 24 into 6 minus 6, 6, minus 21, 3 minus 9, 24, 0 and 8 into B. Matrix B is 1, 1 and 4. So this will be equals to minus 1 by 24 into 6 minus 6 plus 24, minus 21 plus 3 minus 36, and 24 plus 0 plus 32, which is equals to minus 1 upon 24. The values will be 24, minus 54 and 56. Multiplying by minus 1 by 24, here it will be minus 1, 9 by 4 and minus 7 by 3. This is the value of x, and we know that x is equal to u, v and w. So from here we can say that u is equals to minus 1, and we know that u is equal to 1 upon x. So 1 upon x is equal to minus 1. Therefore, x will be equals to minus 1. Similarly, v is equal to 9 by 4. We know that v is 1 upon y. So 1 upon y will be equal to 9 by 4. So here 9y is equal to 4 and y will be equals to 4 by 9. Similarly, w is equal to minus 7 by 3 and w is equal to 1 upon z. So 1 upon z will be equals to minus 7 upon 3. So it will be minus 7z is equal to 3. Therefore, z will be equals to minus 3 upon 7. Now, we know that these are the value for x, y and z. And let x is equal to alpha, y is equal to alpha and z is equals to gamma. See, there are three roots, which is alpha, beta and gamma. So we have x is equal to minus 1, y is equal to 4 by 9 and z is equal to minus 3 by 7. Here x is equal to alpha, y is equal to beta and z is equal to gamma. Therefore, we have alpha is equal to minus 1, beta is equal to 4 by 9 and gamma is equal to minus 3 upon 7. Now we have calculated the value for alpha, beta and gamma. In the question, we have to find alpha square plus gamma square, which will be equals to minus 1 square plus minus 3 by 7 square, which is equal to 1 plus 9 upon 49, which gives 49 plus 9 upon 49, which is equal to 58 upon 49. And this is equals to 5 into beta. Therefore, we can say that this is equals to 5 beta. So, alpha square plus gamma square is equals to 5 into beta. Therefore, we can say that the correct option here is 5 into beta, which is option number A here. Next question is summation of k is equal to 1 to 6 sine 2 pi k upon 7 minus I cos 2 pi k upon 7 is equal to. Here in this expression, we have to find its value. So taking minus I common, it will be summation of k is equal to 1 to 6 cos 2 pi k upon 7 plus I sine 2 pi k upon 7, which will be equals to minus I into 1 plus alpha square plus so on up to alpha power 6 minus 1, which is equals to minus I into 0 minus 1, which is equal to I. We know that I square is equal to minus 1. So on further solving this part, we get minus I into 0 minus 1, which is equals to plus I. Therefore, we can say that the correct option here is option number C. Next question is, if x plus iy power 1 by 3 is equals to a minus ib, then the value of x upon 2a plus y upon 2b is. Our expression is given here, which is x plus iy power 1 by 3 is equals to a minus ib. On cubing both the sides, it will be x plus iy power 1 by 3 into 3 is equals to a minus ib whole cube. On further solving, it will be equals to x plus iy is equals to a minus ib whole cube. We know that there is an identity which is x minus y whole cube is equals to x cube minus y cube minus 3x square y plus 3xy square. Applying this identity here, this will be equals to x plus iy is equals to a cube minus ib cube minus 3 into a square into ib plus 3 into a into ib square. Therefore, x plus iy is equals to a cube minus I cube into b cube minus 3a square ib plus 3a b square I square, which will be equals to a cube minus of minus I into b cube minus 3a square into bi minus 3ab square, because we know that I square is equal to minus 1. So the expression becomes x plus iy is equal to a cube plus I into b cube minus 3a square bi minus 3ab square. Now, it can be written as x plus iy is equals to a cube minus 3ab square plus, taking I common, it will be b cube minus 3a square b. You can see this, that left hand side is also in the form x plus iy and right hand side is also in the form x plus iy. So we can say that x is equal to a cube minus 3ab square, and we can also say that y is equal to b cube minus 3a square b. So it will be b cube minus 3a square b. Now we have to calculate the value, which is x upon 2a plus y upon 2b. So putting the values for x and b here, this will be equals to a cube minus 3ab square divided by 2a plus b cube minus 3a square b divided by 2b. Taking a common, it will be a square minus 3b square divided by 2a plus, taking b common, it will be b square minus 3a square divided by 2b. A and a will be cancelled and b will be cancelled. It can be written as a square minus 3b square plus b square minus 3a square divided by 2, because 2 is common here. Therefore, it will be a square minus 3a square is minus 2a square minus 3b square plus b square is minus 2b square divided by 2. Taking 2 common, it will be minus a square minus b square divided by 2. Now multiplying by minus 2 in the numerator, it will be minus 2 into 2 into minus a square minus b square divided by 2. Taking minus common, it will be 4 into a square minus b square divided by 2, which is equals to 2 into a square minus b square. This is the required value for the given expression, which is x upon 2a plus y upon 2b. Therefore, we can say that the correct option is 2 into a square minus b square, which is option number A here. Next question is, a true statement among the following identities is. Among all the following identity, the correct identity is cos 5 theta is equal to 16 cos power 5 theta minus 20 cos cube theta plus 5 cos theta. Now let us see a proof of this identity. Here cos 5 theta can be written as cos 3 theta plus 2 theta, which will be equals to cos A plus B. So it will be cos A sin B minus sin A cos B. So it can be written as cos 3 theta into sin 2 theta minus sin 3 theta into cos 2 theta, which is equals to cos 3 theta into cos 2 theta minus half of cos theta minus cos 5 theta. On further solving it, it will be equals to 4 cos cube theta minus 3 cos theta into 2 cos square theta minus 1 by 2 cos theta plus 1 by 2 cos 5 theta. Now we know that cos 5 theta by 2 will be equals to 8 into cos power 5 theta minus 6 into cos cube theta minus 4 cos cube theta plus 3 cos theta minus cos theta upon 2. So cos 5 theta by 2 will be equals to 8 cos power 5 theta minus 10 cos power 5 theta plus 5 cos theta, which is equals to left hand side is cos 5 theta and taking 2 on the right hand side, it will be equals to 16 cos power 5 theta minus 20 cos cube theta plus 5 cos theta. Therefore, we can say that this identity is the correct identity. So we can say that the correct identity is option number D here. Next question is, if x is equals to minus 5 plus 2 under root minus 4, then the value of x power 4 plus 9x cube plus 35x square minus x plus 4 is. It is given that x is equals to minus 5 plus 2 into under root of minus 4. This can be written as x is equal to minus 5 plus 2I into 2. X will be equals to minus 5 plus 4I. Or we can write it as x plus 5 is equal to 4I. Now squaring on both sides, it will be x plus 5 whole square is equal to 4I whole square. Applying the formula for a plus b whole square, it will be x square plus 10x plus 25 is equal to 16I square. So it will be x square plus 10x plus 25 is equals to minus 16, because we know that the value of I square is minus 1. Taking all the terms on one side, it will be x square plus 10x plus 25 minus 16 will be plus 16 is equals to 0. So the equation becomes x square plus 10x plus 41 is equals to 0. Now we have to calculate the value for x power 4 plus 9x cube plus 35x square minus x plus 4. It will be equals to x square plus 10x plus 41 into x square plus x minus 4 minus 160. You can see that the value of x square plus 10x plus 41 is 0. So it will be 0 into x square plus x minus 4 minus 160. So it will be 0 minus 160, which is equals to minus of 160. Therefore, we can say that the correct answer for this question is minus of 160, which is option number C here. Next question is, alpha and beta are the roots of the equation x square minus 10x minus 8 is equals to 0 with alpha is greater than beta if alpha power sub power n is equal to alpha power n minus beta power n for n belongs to n, then the value of 8n minus 8a8 upon 5a9 is. It is given that alpha and beta are the roots of this equation. It means that it should satisfy the equation. So it can be written as alpha square minus 10 alpha minus 8 is equal to 0. Let this be equation number 1. Multiplying by alpha power 8 in equation number 1, we get alpha power 10 minus 10 alpha power 9 minus 8 alpha power 8 is equals to 0. Similarly, beta is also the root of the equation. So it can be written as beta square minus 10 beta minus 8 is equals to 0. Let this be equation number 2. Again, multiply by beta power 8 in equation number 2. Then we get beta power 10 minus 10 into beta power 9 minus 8 into beta power 8 is equal to 0. It is given that an is equal to alpha power n minus beta power n. So a10 will be equals to alpha power 10 minus beta power 10 and a8 will be equals to alpha power 8 minus beta power 8. Similarly, a9 will be equals to alpha power 9 minus beta power 9. So subtracting equation 1 and equation 2, we will get alpha power 10 minus 10 into alpha power 9 minus 8 into alpha power 8 minus beta power 10 plus 10 into beta power 9 plus 8 into beta power 8 is equal to 0. So it can be written as alpha power 10 minus beta power 10 minus 10 into alpha power 9 minus beta power 9 minus 8 into alpha power 8 minus beta power 8 is equals to 0. We know that alpha power 10 minus beta power 10 is a10 minus alpha power 9 minus beta power 9 is a9. So it will be 10 into a9 minus 8 into alpha power 8 minus beta power 8 is a8. So it will be a8. It is equals to 0. Now it can be written as a10 minus 8a8 is equals to 10a9. Now dividing both the sides by 5a9. On dividing it, we will get a10 minus 8a8 divided by 5a9 is equals to 10a9 divided by 5a9, which is equals to 2. Therefore, we can say that the correct answer for this question is 2. So out of all the given options, the correct option here is option number D. Next question is the number of real values of m so that the equation x square plus 2m plus 1 into x plus m is equal to 0 has real roots is. This is a very important question. This kind of question always comes in the exam. Equation is given here. We know that the standard quadratic equation is ax square plus bx plus c is equal to 0. On comparing both the equation, a is equals to 1, b is equal to 2m plus 1 and c is equal to m. Now, let us calculate the discriminant. We know that discriminant is b square minus 4ac. So b square minus 4ac will be equals to 0 because it is given that they are the real values. So putting the value here for b is 2m plus 1 whole square minus 4 into 1 into m is equal to 0. So it will be 2m plus 1 whole square minus 4m is equal to 0. Here minus 4m will be equals to 0. So m will be equals to 0 upon minus 4. Therefore, we can say that m will be equals to 0. So the value of m here is 0. Therefore, we can say that the correct option is option number B here. Next question is, all the pairs x, y that satisfy the inequality 2 power root equation, and the equation is 2 power under root of sine square x minus 2 sine x plus 5 into 1 upon 4 power sine square y is less than or equal to 1 also satisfy the. We have to find that it satisfy which of the following condition. This expression can be written as 2 power under root of sine square x minus 2 sine x plus 5 can be written as 4 plus 1 into 1 upon 4 can be written as 2 square. 2 square sine square y is less than or equal to 1. So it becomes 2 power under root of sine x minus 1 square plus 4. It will be a minus b whole square into 1 upon 2 square sine square y is less than or equals to 1. So we can take this expression on the right hand side. So it will be on the numerator. So this will be equals to 2 square sine square y. We know that there is a condition if a is greater than 1 and a power m is less than equals to a power n, then m is less than or equals to n. So we have to use this condition in this given question. Therefore, here a is equal to 2 and a is greater than 1. It means that under root of sine x minus 1 whole square plus 4 is less than or equals to 2 sine square y. Now we have to find its range. So range of under root of sine x minus 1 square plus 4 is 2 and 2 root 2. Now let us see how we have calculated the range. We know that sine x lies between minus 1 and 1. So sine x minus 1 whole square will lie between 4 and 0. Similarly, sine x minus 1 whole square will lie between 4 and plus 4 and 8. See, the first condition here is sine x lie between minus 1 and 1. So sine x minus 1 whole square lies between 0 and 4. And therefore sine x minus 1 whole square plus 4 lies between 4 and 8. Now we have to find its root. So under root of sine x minus 1 whole square plus 4 will lie between 2 and 2 root 2. Under root of 4 is 2 and under root of 8 is 2 root 2. In this way we have calculated the range. Similarly, for another part which is 2 sine square y, the range will be 0 and 2. Now, the above inequality holds if under root of sine x minus 1 whole square plus 4 is equal to 2 is equal to 2 sine square y. So from here we can say that sine x is equal to 1 and sine square y is also equals to 1. So we can say that sine x is equal to sine square y, or we can write it as sine x is equals to modulus of sine y. This is the condition for the given inequality. Therefore, we can say that the true condition that satisfy the given inequality is sine x is equal to modulus of sine y, which is option number D here. Next question is the number of solutions for the equations x plus y plus z is equal to 1, x square plus y square plus z square is equal to 1, and x cube plus y cube plus z cube is equal to 1 is. You can see that Here the power is 1. Here the power is increased by 1, which is 2. Again the power is increased by 1, which is 3. And in this given equations, there are 3 variables. It means that it will have 3 values. One value for x, one value for y, and one value for z. Therefore, we can say that the possible number of solutions for this equations is 3. So option number B is the correct option for this question. Next question is a very interesting question. Given 5 different green toys, 4 different blue toys, and 3 different red toys, how many combinations of toys can be chosen taking at least one green and one blue toy? In this question, we have to understand that at least one green toy can be selected out of 5 green toys in 2 power 5 minus 1 combination, which is equals to 31 ways, or we can say that 31 possible combination. Similarly, at least one blue toy can be selected out of 4 in 2 power 4 minus 1 ways, which is equal to 15 ways. Now, for the red toys, there is no restriction. It means that we can include it or we cannot include it. Therefore, there are 2 ways of disposing each of the red toys. Therefore, total number of selection of red toys will be 2 power 3, which is equal to 8. Therefore, the required number of ways will be equals to 31 into 15 into 8, which is equals to 3720. Or according to the given question and the options, the correct option here is 31 into 15 into 8. So option number D is the correct option here. Moving on to the next question. This question comes from binomial expansion. If 2nc3 is to nc3 is equals to 12 is to 1, then n is equal to 2nc3 can be written as c 2n comma 3 is to c n comma 3 is equals to 12 is to 1. Now, it can be written as 2nc3 divided by nc3 is equal to 12 upon 1, since the ratio is given here. Therefore, 2nc3 will be equals to 12 into nc3. Now, on further simplifying it, it will be 2n minus 1 into 2n minus 2 divided by 3 factorial. It is equal to 12 into n minus 1 divided by 2 factorial. On further solving, it will be 4 into 2n minus 1 divided by 6 is equals to 12 upon 2. Now, further cross multiplying, it will be 2n minus 1 is equals to 9. So 2n will be equals to 9 plus 1, which is 10. So n will be equals to 5. Therefore, we can say that the required value for n is 5 here. So the correct option here is option number A. Next question is, there are 4 oranges, 5 apples, 7 mangoes in a fruit basket. The number of ways of selecting at least one fruit from among the fruits in the basket is. You know that in selection of fruits, fruits of same type are treated as identical. Therefore, number of selection of oranges from 4 oranges will be equals to 4 plus 1. This is the number of selection of any number of oranges from 4 oranges. Similarly, the number of selection of any number of apples from 5 apples will be 5 plus 1. Similarly, Number of selections of any number of mangoes from 7 mangoes. We know that total number of mangoes are 7. So number of ways of selecting any number of mangoes from 7 mangoes will be 7 plus 1. Now, total number of selection of fruit will be 4 plus 1 into 5 plus 1 into 7 plus 1, which is equals to 5 into 6 into 8, which is equals to 240. But you have to notice one thing here, that in one of the selection, one is a condition which contains no fruit. In one of all the selections, one contains no fruit. Therefore, excluding one, it means that 240 minus 1 will be 239. We have excluded one fruit because we know that one of in the selections, one will not contain any fruit. Therefore, excluding one, the answer becomes 239. So option number D is the correct answer for this question. Next question is, if 9C3 plus 9C5 is equal to 10CR for some R belongs to N, then R is equal to. See, it is the similar question that we have solved previously. It is given that 9C3 plus 9C5 is equal to 10CR. It can be written as NCR plus NCR plus 2, because we know that 9C3 is NCR. N is 9 and R is 3. So 9C5 will be NCR plus 2 because 3 plus 2 is 5. Now, this will be equals to N plus 1 C R plus 1 because N plus 1 is 10. Therefore, R plus 1. So we can say that 10CR is equals to 10C4. So we can say that R is equals to 4. Therefore, the required value of R is 4, which is option number B here. Next question is, if the equivalent partial fraction of x cube divided by 2x minus 1 into x plus 2 into x minus 3 is of the form a plus b upon 2x minus 1 plus c upon x plus 2 plus d upon x minus 3, then the value of a plus b plus c is. You can see that in both the sides, the denominator is same. So multiplying by 2x minus 1, x plus 2 and x minus 3 on both the sides, it becomes x cube is equals to a into 2x minus 1 into x plus 2 into x minus 3 plus b into x plus 2 into x minus 3 plus c into 2x minus 1 into x minus 3 and plus d into x minus 3 x plus 2 and 2x minus 1. We have taken the LCM here and we have multiplied, or we can say that by cross multiplication, this is the step, and the denominator will be cancelled because in both sides it is equal. Now x cube will be equals to a into 2x square plus 3x minus 2 into x minus 3 plus b into x square minus x minus 6 plus c into 2x square minus 7x minus 3. It will be plus 3 plus d into 2x square plus 3x minus 2. Now, on further multiplying, it becomes x cube is equals to a into 2x cube minus 6x square plus 3x square minus 9x minus 2x plus 6 plus b into x square minus x minus 6 plus c into 2x square minus 7x plus 3 plus d into 2x square plus 3x minus 2. Now, on multiplying it, it will be x cube is equal to a into 2x cube minus 3x square minus 11x plus 6 plus b into x square minus x minus 6 plus c into 2x square minus 7x plus 3 plus d into 2x square plus 3x minus 2, which is equals to x cube is equal to, taking x cube common, the terms will be 2a, plus taking x square common, the terms will be minus 3a plus b plus 2c plus 2d. Similarly, taking x common, the remaining terms will be minus 11a minus b minus 7c plus 3d. And at last, the numbers will be 6a minus 6b plus 3c minus 2d. Now, for the coefficient of x cube, comparing here on the left hand side and right hand side, the coefficient of x cube will be 2a is equal to 1. So a will be equal to 1 by 2. Comparing the coefficient of x square, minus 3a plus b plus 2c plus 2d will be equals to 0. Comparing the coefficient of x, it will be minus 11a minus b minus 7c plus 3d is equal to 0. And comparing the numbers, it will be 6a minus 6b plus 3c minus 2d is equal to 0. We have given equations here. On solving all this equation, we get a plus b plus c is equals to 4 upon 25. Therefore, we can say that the value for a plus b plus c is 4 upon 25. So option number B is the correct option here. Next question is a question that comes from trigonometry part. If cos theta minus sin theta is equals to under root of 5 into sin theta, then cos theta plus 4 sin theta is equal to. Here we can write this expression as cos theta is equal to under root of 5 sin theta plus sin theta, taking minus sin theta on the right hand side. So cos theta will be equals to under root of 5 plus 1 into sin theta. Or we can write it as cos theta divided by under root of 5 plus 1 is equals to sin theta. Now, rationalizing the left hand side, it will be cos theta divided by under root of 5 plus 1 into under root of 5 minus 1 divided by under root of 5 minus 1 is equal to sin theta. So it will be cos theta into under root of 5 minus 1, and the denominator will be a square minus b square, because you can see that it is a plus b and a minus b. So it will be under root of 5 square minus 1 square is equals to sin theta. So it becomes under root of 5 cos theta minus cos theta divided by 5 minus 1 is 4 is equals to sin theta. Now, it will be under root of 5 cos theta minus cos theta is equals to 4 sin theta. It can be written as 4 sin theta plus cos theta is equals to under root of 5 cos theta, and this is the value that we have to calculate. You can see that in the question we have to calculate cos theta plus 4 sin theta, and we have got the value, which is cos theta plus 4 sin theta is equal to under root of 5 cos theta. So we can say that the correct option here is option number D. Next question is, In a triangle, tan A by 2 into tan B by 2 plus tan B by 2 into tan C by 2 plus tan C by 2 into tan A by 2 is equal to, we have to find its value. We know that in a triangle, all the angles are equal to 180 degree. It means that A plus B plus C is equals to 180 degree. So we can write it as A plus B is equal to 180 degree minus C, or we can write that A by 2 plus B by 2 will be equal to 90 degree minus C by 2. Now we have to calculate the value for tan A by 2 into tan B by 2 plus tan B by 2 into tan C by 2 plus tan C by 2 into tan A by 2. We know that tan A by 2 plus B by 2 is equals to tan A by 2 plus tan B by 2 divided by 1 minus tan A by 2 into tan B by 2. So this expression will be tan A by 2 into tan B by 2 plus tan C by 2, and it will be tan A by 2 plus tan B by 2, which will be equals to tan A by 2 into tan B by 2 plus tan C by 2 into, from here you can see that tan A by 2 plus tan B by 2 will be equals to tan A by 2 plus B by 2 into 1 minus tan A by 2 into tan B by 2. We have substituted the value here. Now further it will be equals to tan A by 2 into tan B by 2 plus tan C by 2 tan 90 degree minus C by 2. We know that A by 2 plus B by 2 is equal to 90 degree minus C by 2 into 1 minus tan A by 2 into tan B by 2. On further solving it, it will be equals to tan A by 2 into tan B by 2 plus tan C by 2 into C. We know that tan 90 minus theta is cot theta, and cot theta can be written as 1 upon tan theta. So it will be 1 upon tan C by 2 into 1 minus tan A by 2 into tan B by 2. So tan C by 2 and tan C by 2 will be cancelled. So the remaining terms will be tan A by 2 into tan B by 2 plus 1 minus tan A by 2 into tan B by 2. You can see that here tan A by 2 into tan B by 2 is positive and here there is negative. So this term and this term will be cancelled. So the remaining term will be 1. Therefore, we can say that its value is equals to 1. Therefore, the correct option is option number B here. Next question is sec square x plus 5 into tan x plus 5 is equal to. It can be written as tan square x plus 1 plus 5 tan x plus 5, because we know that sec square x is equal to tan square x plus 1. Further, it can be written as tan x square plus 6, 1 plus 5 is 6, plus 5 tan x, which will be equals to tan x square plus 5 tan x plus 6. We have arranged the terms. Now we have tan x square plus 5 tan x plus 6. Now we have to use here splitting the middle term method. So by splitting the middle term method, it can be written as tan x square plus 3 tan x plus 2 tan x plus 6. Taking tan x common from the first two terms, the remaining terms will be tan x plus 3. Taking 2 common from the next two terms, the remaining terms will be tan x plus 3. So the factors will be, you can see that tan x plus 3 is again common. So it will be tan x plus 3 and another factor will be tan x plus 2. This is the required answer here. Therefore, we can say that out of all the given options, option number A is the correct option, which is tan x plus 2 and tan x plus 3. So option number A is the correct option here. Next question is, let alpha and beta be two real numbers such that alpha minus beta lies between pi and 3 pi. If sine alpha plus sine beta is equal to minus 21 upon 65 and cos alpha plus cos beta is equals to minus 27 upon 65, then cos beta minus alpha upon 2 is equal to. We know that alpha minus beta lies between pi and 3 pi. Therefore, alpha minus beta by 2 will lie between pi by 2 and 3 pi by 2. So we can say that alpha minus beta by 2 belongs to second and third quadrant. And we know that in second and third quadrant, cos is negative. Two more expressions are given, which is sine alpha plus sine beta is equals to minus 21 upon 65 and cos alpha plus cos beta is equals to minus 27 upon 65. On squaring both the terms, we will get sine square alpha plus sine square beta plus 2 sine alpha into sine beta is equals to 441 upon 65 square. Let this be equation number 1. On squaring the other expression, we will get cos square alpha plus cos square beta plus 2 cos alpha into cos beta is equals to 729 divided by 65 square. Let this be equation number 2. Now, adding both the equation, which is equation 1 and 2, we will get sine square alpha plus cos square alpha plus sine square beta plus cos square beta plus 2 into cos alpha cos beta plus sine alpha sine beta is equals to 441 plus 729 divided by 65 square. We know that sine square alpha plus cos square alpha will be 1. Again, sine square beta plus cos square beta will be 1 plus 2 into cos alpha into cos beta plus sine alpha into sine beta is equals to 1170 divided by 65 square. I hope up to here all the steps are clear to you. We have just simplified the steps. Now, taking 2 common, it will be 1 plus cos alpha minus beta is equals to 1170 divided by 65 square, and 1170 will be cancelled by 2, so it will be 585. So we can say that 1 plus cos theta is equal to 2 cos square theta. So putting the value here, the term becomes 2 cos square alpha minus beta upon 2 is equals to 585 divided by 65 into 65. So we can say that cos square alpha minus beta by 2 will be equals to 9 upon 65 into 2. On cancelling this term, it becomes 9 upon 65 into 2, which is equal to 9 upon 130. Taking square root, cos of alpha minus beta upon 2 will be equals to plus minus 3 upon under root of 130. So since cos is negative in second and third quadrant, so cos alpha minus beta by 2 will be equals to minus of 3 upon under root of 130. Therefore, we can say that the value for cos alpha minus beta upon 2 is minus 3 upon under root of 130, which is option number B here. Next question is, if cosec hx is equals to 4 by 5, then cos hx is equal to, cos hx will be equals to under root of 4 square plus 5 square divided by 4 square, which is equals to under root of 16 plus 25 divided by 16, which is equals to under root of 25 plus 16 will be 41 upon 16. So we can say that the value of cos hx is under root of 41 divided by 16. Therefore, option number D is the correct option here. Next question is, let x in R and modulus of x is less than 1, then tan h inverse x is equal to. In this question, there is a very short trick to solve it. Let us look at the options. So let us look at the first option here. If tan h inverse x is equals to 1 by 2 log of 1 plus x divided by 1 minus x, here put x is equals to 1 by 2. So it becomes tan h inverse 1 by 2 will be equals to 1 by 2 of log 1 plus 1 by 2 divided by 1 minus 1 by 2. On further solving it, it will be equals to 1 by 2 log 3 by 2 divided by 1 by 2. On further solving it, it will be 1 by 2 log 3 by 2 minus 1 by 2. We know that log m upon n is log m upon n, and it is evaluated as log m minus n. So it will be 1 upon 2 into log of 0. So it will be 1 by 2 into 0. We know that log 0 is 0. So it will be 0. Hence, it satisfies the given equation. So we can say that option number 1 is the correct option for this question, which is 1 by 2 log 1 plus x upon 1 minus x. So option A is correct option here. Next question is a very, very interesting question. A farmer owns a triangular plot in Gunter. He measures the length of the sides of his property as 4 centimeter, 5 centimeter, and 7 centimeter. Then the area of land of the farmer in square centimeter is. It is given that it is a triangle and the sides are, let A is equal to 4 centimeter, B is equal to 5 centimeter, and C is equal to 7 centimeter. We have to find the area of this triangle. We know that when 3 sides are given, we have to use the Heron's formula here. So first we have to calculate the semi-perimeter, which is S. It is equals to A plus B plus C by 2, which is equal to 4 plus 5 plus 7 by 2, which gives 16 by 2, which is equal to 8. So we can say that S is equals to 8. Area of a triangle is equal to under root of S into S minus A into S minus B into S minus C, which is equal to under root of S is 8. 8 minus 4 into 8 minus 5 into 8 minus 7. On further solving this, it will be equals to under root of 8 into 4 into 3 into 1, which is equals to, see, 8 can be written as 4 into 2 and the remaining terms are 4 into 3 into 1. Now, since 4 is in square root, so it can be taken out. So if 4 comes out of the square root, it becomes 2. Again, one more 4 comes out, it becomes 2. Under root of 2 into 3 into 1. So it becomes 4 under root of 2 into 3 is 6. Therefore, we can say that the required area for this triangle is 6. So option number B is the correct option, which is 4 into under root of 6. I hope this question is clear to you. In this question, we only have to use the Heron's formula here. Next question is also for a triangle. In a triangle, if B is equal to 5 and C is equal to 6 and tan A by 2 is equal to 1 upon root 2, then A is equal to. We know that there is an identity which is cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta. So here cos A will be equals to 1 minus tan square A by 2 divided by 1 plus tan square A by 2. On putting the value, cos A will be equals to 1 minus 1 by 2 divided by 1 plus 1 by 2, which is equal to 1 by 2 divided by 3 by 2, which is equals to 1 by 2 into 2 by 3. So it gives 1 upon 3. Now, using the cosine rule, we know that A square is equal to B square plus C square minus 2BC into cos A. We have calculated the value for cos A. Cos A is equal to 1 upon 3. And putting the value of B and C here, it becomes A square is equal to B is 5. So it will be 5 square plus C is 6. It will be 6 square minus 2 into 5 into 6 into cos A. Cos A is 1 upon 3. So A square will be equals to 25 plus 36 minus 2 into 5 into 6 into 1 by 3. 3 and 6 will be cancelled. So it becomes A square is equal to 25 plus 36 minus 2 into 5 is 10 and 10 into 2 is 20. So it will be A square is equal to 41. So A will be equals to under root of 41. Therefore, we can say that the value of A here is under root of 41, which is option number A here. Next question is, in a triangle ABC, S into R1 minus R divided by A plus R2 minus R divided by B plus R3 minus R divided by C is equal to. We have to find its value. We know that since it is a triangle, therefore R is equal to delta upon S. So R1 will be equals to delta upon S minus A. R2 will be equals to delta upon S minus B. And R3 will be equals to delta upon S minus C. On substituting this value, it becomes S into 1 by A into delta upon S minus A minus delta upon S plus 1 by B into delta upon S minus B minus delta upon S plus 1 by C into delta upon S minus C minus delta upon S. On taking the LCM, this expression becomes S into 1 by A into delta S minus delta A, minus and minus will be plus, divided by S into S minus A plus delta upon S into S minus B plus delta upon S into S minus C. Here delta S minus delta S will be cancelled and A will be cancelled. So it will be S into R1 by S plus R2 by S plus R3 by S. So it can be written as S into R1 plus R2 plus R3 divided by S. And here S and S will be cancelled. So it will be R1 plus R2 plus R3. Therefore, we can say that the required value for this question is R1 plus R2 plus R3, which is option number B here. Next question is 7i minus 4j plus 7k, I minus 6j plus 10k is equal to I minus 3j plus 4k, 5i minus j plus 5k respectively, then ABCD is. Consider a figure and let this figure be ABCD. Now, according to the question, we have OA vector is equals to 7i minus 4j plus 7k. OB vector is equals to I minus 6j plus 10k. OC vector is equals to minus I minus 3j plus 4k. And OD vector is equals to 5i minus j plus k. Therefore, AB vector will be equals to minus of 6i minus of 2j plus 3k. So, modulus of AB vector will be equals to under root of 6 square plus 2 square plus 3 square, which is 36 plus 4 plus 9, which is equals to under root of 49, which is equal to 7. Similarly, BC vector will be equals to minus 2i plus 3j minus 6k, and therefore modulus of BC vector will be equals to under root of 4 plus 9 plus 36, which is equal to under root of 49, which is equal to 7. Now, CD vector will be equals to 6i plus 2j minus 3k. Therefore, modulus of CD vector will be equals to under root of 36 plus 4 plus 9, which is equal to under root of 49, which is equal to 7. And DA vector will be equals to 2i minus 3j plus 6k. Therefore, modulus of DA vector will be equals to under root of 4 plus 9 plus 36, which is equals to again under root of 49, which is equal to 7. You can see that here modulus of AB vector is equal to modulus of BC vector is equal to modulus of CD vector is equal to modulus of DA vector. Now let us calculate AC vector. AC vector will be equals to minus 8i plus j minus 3k. Therefore, modulus of AC vector will be equals to under root of 64 plus 1 plus 9, which is equal to under root of 74. And BD vector will be equals to 4i plus 5j minus 9k. Therefore, modulus of BD vector will be equals to under root of 16 plus 25 plus 81. So it will be equals to under root of 122. We know that AC vector into BD vector will be equals to 0. So let us multiply AC vector into BD vector. It will be minus 32 plus 5 plus 27. It is equals to 0. Therefore, we can say that AC vector is perpendicular to BD vector, and modulus of AC vector is not equal to modulus of BD vector, because AC vector modulus is root 74 and modulus of BD vector is root 122. And we know that modulus of AB vector is equal to modulus of BC vector is equal to modulus of CD vector is equal to modulus of DA vector. It means that the given figure is not a parallelogram, but it is a quadrilateral. Therefore, we can say that ABCD is a quadrilateral, which is not a parallelogram, which is option number C here. So the correct option is option number C. Next question is, M and N are the midpoints of the sides BC and CD of a parallelogram ABCD respectively. Then AM vector plus AN vector is equal to. Consider this as a parallelogram A, B, C and D. It is given that M is the midpoint for BC. So let this point be M, and N is the midpoint of CD. So let this point be N. We have to find AM plus AN vector. Since M is the midpoint of BC, therefore BM will be equals to MC. And since N is the midpoint of BC, therefore CN will be equals to DN. We know that AB vector will be equals to DC vector, and both of this will be equal to A vector. because it is given that it is a parallelogram, therefore AB vector will be equal to DC vector. And similarly, AD vector will be equals to BC vector, which will be equals to B vector. Also, AM vector will be equals to AB vector plus BM vector. And AN vector will be equals to AD vector plus DN vector. Therefore, on adding both this value, because we have to calculate AM vector plus AN vector, it will be equals to AB vector plus BM vector can be written as BC vector by 2. So it will be BC vector by 2 because it is half of BC. You can see that BM is half of BC plus AD vector. Again, DN vector can be written as DC vector upon 2. So it will be plus DC vector upon 2, which will be equals to 3 by 2 into AB vector plus BC vector, which is equal to 3 by 2 into AC vector. This is the required value for AM vector plus AN vector. Therefore, we can say that the correct option here is 3 by 2 into AC vector, which is option number D here. Next question is, in a triangle ABC, O is the circumcenter, G is the centroid, then modulus of OG vector whole square is equal to. We know that if in a triangle ABC, G is the centroid, then its square of the modulus is equal to R square minus 1 by 3 into A square plus B square plus C square. Now multiplying 1 by 3 inside the bracket, so it will be R square minus 1 by 3 A square minus 1 by 3 B square minus 1 by 3 C square. So it will be written as R square minus 1 by 3 A square minus 1 by 3 B square minus 1 by 3 C square. So again it can be written as R square minus of 1 by 3 into A square plus B square plus C square. Multiplying it again by 1 by 3, it becomes R square minus 1 by 3 into 3 into A square plus B square plus C square, which gives R square minus 1 upon 9 into A square plus B square plus C square. So we can say that modulus of OG vector whole square will be equals to R square minus 1 by 9 into A square plus B square plus C square, which is option number C here. Next question is also from the vectors, and it is a very important question. This kind of question always comes in the exam. Three vectors, A vector, B vector, and C vector, satisfy the condition. And the condition is A vector plus B vector plus C vector is equal to 0. Modulus of A vector is equal to 1. Modulus of B vector is equal to 3. And modulus of C vector is equal to 4. We have to calculate A vector dot product B vector plus B vector dot product C vector plus C vector dot product A vector. Therefore, let lambda is equal to this expression. Now, modulus of A vector plus B vector plus C vector whole square will be modulus of A square plus modulus of B square plus modulus of C square plus 2 into A vector dot product B vector plus B vector dot product C vector plus C vector dot product A vector. We know that this term is equal to lambda. So the equation becomes zero is equal to 1 plus 9 plus 16 plus 2 lambda. We also know that A vector plus B vector plus C vector is equal to 0. So its square will be also 0. Therefore, 2 lambda will be equals to minus of 26. And lambda will be equals to minus of 26 upon 2, which is equal to minus of 13. Therefore, we can say that here the value of lambda is equal to minus of 13, or we can say that the value of a vector dot b vector plus b vector dot c vector plus c vector dot a vector is minus of 13. So option number C is the correct option here. Next question is also from the vectors. Let OA vector is equals to minus 4i vector plus 3k vector. OB vector is equals to 14i vector plus 2j vector minus 5k vector. It is given that OD vector bisects angle AOB and modulus of OD vector is equal to under root of 6. And we know that modulus of OD vector will be equals to under root of x square plus y square plus z square. We have to calculate OD vector. So we have to just check the options here which will satisfy this given expression, which is under root of x square plus y square plus z square. So let us check the first option. The first option here is I vector plus j vector plus 2k vector. Here x is equals to 1, y is equal to 1 and z is equal to 2. On putting the values here, we get 1 square plus 1 square plus 2 square, which is equal to under root of 1 plus 1 plus 4, which is equal to under root of 6. And we know that modulus of OD vector is under root of 6. It means that first option is the correct option, which is I vector plus j vector plus 2k vector. See, in this type of question, all you have to do is you have to look for the option that satisfy the given value, because it is already given that modulus of OD vector is under root 6. So you just have to put the values in this formula. And if you get under root 6, then that is the correct option. So here option number A is the correct option for this question. Moving on to next question. Next question is a very, very simple question. The marks are given and we have to find mean deviation about the mean for the following data. So the marks obtained are 0 to 20, 20 to 40, 40 to 60, 60 to 80, and 80 to 100. And the number of students are 10, 8, 12, 9, and 11. So xi, or we can say the average marks will be 10, 30, 50, 70, and 90. We have to calculate the mean deviation about mean. So first let us calculate the mean. Mean will be equals to 10 into 10 plus 8 into 30 plus 12 into 50 plus 9 into 70 plus 11 into 90. We know that mean is equal to summation of fi xi upon summation of fi. Here, this is number of students and this is fi, and xi is the average marks. So fi into xi and their sum divided by summation of fi. Summation of fi will be 10 plus 8 plus 12 plus 9 plus 11. So it will be equals to 100 plus 240 plus 600 plus 630 plus 990 divided by 50, which will be equals to 2560 divided by 50. 0 and 0 will be cancelled. 256 divided by 5 will be 51.2. This is the mean. Now we have to calculate the mean deviation. So mean deviation will be equals to 10 into 10 minus 51.2. We know that mean deviation is modulus of xi minus x bar and their summation plus 8 into 30 minus 51.2. Here the mean is considered as x bar. Okay. So now, and further putting the values, it will be 12 into 50 minus 51.2 plus 9 into modulus of 70 minus 51.2 plus 11 into modulus of 90 minus 51.2 divided by sum of the value which is given in the question, which is number of students. So 10 plus 8 plus 12 plus 9 plus 11. On further calculating the value, it will be 10 into 41.2 plus 8 into 21.2 plus 12 into 1.2 plus 9 into 18.8 plus 11 into 38.8 whole divided by 50. On further multiplying, we get 412 plus 169.6 plus 14.4 plus 169.2 plus 426.8 whole divided by 50. On adding all these values, we get 1192 divided by 50, which is approximately equal to 22.08. So we can say that the correct option here is option number D, which is 22.08. This is the mean deviation about mean for the given question. I hope this question is clear to you. Next question is also a very interesting question. And the question is, 3 students X, Y, and Z appear for an examination. The probability of X passing the examination is 1 by 5. So we can write that P of X is equal to 1 by 5. The probability of Y passing the examination is 1 by 4. So P of Y is equal to 1 by 4. And the probability of Z failing the examination is 2 by 3. It means that P of Z bar or P of Z complement is 2 by 3. If P of Z complement is 2 by 3, then P of Z will be 1 minus 2 by 3, which is equal to 1 by 3. So we can say that P of Z is equal to 1 by 3. We have to find the probability that at least 2 of them pass the exam is. So we have the values. Therefore, probability of at least 2 of them pass the exam will be equals to 2 by 3 into 1 by 4. This will be cancelled, so it will be 1 by 6. So we can say that the required probability here is 1 by 6. Therefore, option number A is the correct option for this question. Next question is also from the probability. And the question is, 2 dice are thrown simultaneously. The probability of getting 2 numbers whose product is even is. We know that when 2 dice are thrown, then the possible outcomes will be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and 1, 6. Similarly, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. Similarly, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6, and 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. These are the possible outcomes when 2 dice are thrown simultaneously. Now, favorable outcomes that is 2 numbers whose product is even are. We have to find 2 numbers whose product is even. So out of all these possible outcomes, the pair of two numbers whose product is even are 1, 2, 1, 4, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 2, 3, 4, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 2, 5, 4, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. These are the number of favorable outcomes whose product is even. Means these are the pairs who have the numbers whose product is even. So the required probability will be favorable outcomes divided by total number of outcomes. You can see that total number of outcomes will be 36, which is 6 into 6. And the favorable outcomes here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and 27. So favorable outcomes upon total number of outcomes. So it will be equals to 3 upon 4. Therefore, we can say that the required probability here is 3 by 4. So option number B is the correct option for this question. Next question is also from the probability, and the question is from a pack of 52 cards, 3 cards are drawn at random. Then the probability that one is S, one is Q, and one is Jack is. See, this kind of question frequently comes in the exam. Last, it came back in 2018. We know that probability shows the relationship between any two variables in the form of a ratio or percentage or proportion, where there is chances of occurrence of one variable and it is expressed in the terms of other variable, which is usually the sample space. So here, for this question, the sample space for event is 52 C3, because from 52 cards, 3 cards are drawn at random, which is equals to 52 factorial upon 3 factorial into 52 minus 3 factorial, which will be equal to 52 factorial upon 3 factorial into 49 factorial, which will be equals to 52 into 51 into 50 into 49 factorial divided by 3 factorial into 49 factorial. 49 factorial and 49 factorial will be cancelled. So the remaining terms will be 52 into 51 into 50 divided by 3 factorial. 3 factorial means 3 into 2 into 1. Now cancelling this term, it will be 2 into 25 is 50. Again 3 into 17 is 51. So now the remaining terms are 52 into 17 into 25, which is equals to 21,100. Now we have to find the probability of getting one ace, one queen, and one jack. Therefore, let the required event be E, and event for getting one ace, one queen, and one jack. Therefore, n of E will be equals to 4 into 4 into 4, which is equal to 64. Now, the required probability will be probability of getting one ace, one queen, and one jack is equals to n of E divided by S. S is the sample space here. We know that n of E is 64 and the sample space is 21,100. So it will be 16 and it will be 5225. Therefore, the required probability is 16 upon 5225. Hence, we can say that the correct option here is option number D, which is 16 upon 5525. Moving on to the next question. Again, you can see that continuously all the questions are coming from probability. There are 4 hotels in a town. If 3 men check into the hotels in a day, then the probability that each checks into a different hotel is. We know that total cases of checking in the hotels will be 4 into 4 into 4, which is equal to 64 because there are 4 hotels and there are 3 people. So if each check every hotel, then the total cases of checking will be 4 into 4 into 4, which is 64. So there are total ways 64. Now, cases when 3 men are checking in different hotels will be 4 into 3 into 2, which is equal to 24 ways. Therefore, the required probability will be 24 upon 64, which is equals to 3 by 8. So we can say that the required probability here is 3 by 8. Therefore, option number C is the correct option here. Next question is, it is given that the discrete random variable is x such that b of n comma p and p of x is equal to 2 is equal to p of x is equal to 3. Then the mean of x is. See, this kind of questions are also very, very important, and this type of question comes many a times in the exam. Not one time, not 2 times, but repeatedly it has come in the exams. We know that there is a formula for the Poisson distribution, and the formula is e to the power minus mu into mu square divided by 2 factorial, because here p of x is equal to 2. This is equal to p of x is equal to 3. So it will be e to the power minus mu cube divided by 3 factorial. So it will be mu square into 3 factorial is equal to mu cube into 2 factorial, because you can see that e power minus mu and e power minus mu will be cancelled, and on cross multiplying we will get mu square into 3 factorial is equal to mu cube into 2 factorial. So from here mu square will be cancelled. So we can say that 3 factorial will be equals to mu into 2 factorial. So mu will be equals to 3 factorial upon 2 factorial, which will be equals to 3 into 2 factorial upon 2 factorial. So we can say that mu is equal to 3. If mu is equal to 3, then mean will be equals to 3 minus p. Therefore, we can say that the required mean for this question is 3 minus p. So the correct option here is option number B. Next question also comes from Poisson distribution, which is a very, very important topic. And the question is, if 3 is the variance of the Poisson distribution, then P of x lies between 1 and 4 is equal to. It is given that 3 is the variance, and we know that variance is denoted by lambda. So lambda is equal to 3, and we have to find P of 1 less than x less than 4. So by using the formula, it will be equals to e power minus 3 into 3 square. Because if x lies between 1 and 4 and the variance is 3, then the value of x can also be 3. So it will be equals to e power minus 3 into 9, which can be written as 9 into e power minus 3. Therefore, option number C is the correct option for this question. I hope all these questions are clear to you, and the concept behind each and every question is also clear to you. Keep learning more and keep scoring high.